Today we're going to go over section 6.6 over rational exponents. So let's read some of the notes and then we will do some examples. A rational exponent is a fraction exponent, just like a rational number can be written as a fraction. To change from a rational exponent to radical form, the numerator is the exponent and the denominator is the root, or the index. So for example, if I have 2 to the 3 over 2 power, in that rational exponent, which is this fraction, that's called a rational exponent, the numerator is the power. It's like a regular power. You could write that as 2 to the third. Okay, and the denominator is the root. So that represents the index. It tells you what root is being taken. So in this case, the denominator is a 2, so that means it's the square root. So if I wrote it using roots and powers, that's what it would look like. So I'm changing from a rational exponent to a radical. Okay, so the rational form, if I were to write the fifth root of x squared, okay, that's in radical form. So the rational form would be x to the 2 over 5. So the power goes in the numerator, and the index of the root is your denominator. Expressions can be combined using the properties of exponents. In simplest form, there can be no negative exponents, no fractional exponent in the denominator. If you have a fraction exponent in the denominator, that means you have a root in the denominator. You can't leave it that way. No complex fraction, so you can't have a fraction in a fraction. And the index is the smallest number possible. So you want to reduce your fractions, your rational exponents, just like any other normal fraction. Okay, so in the first part it says change each of the following into radical form. On number 1, a to the 1/4 is written as a rational exponent. So in radical form, the 4 in the denominator tells you what the root is. So that's the 4th root of a, and the number in the numerator tells you what the power should be. And you don't have to put the 1 there. I mean, it's just a to the first power. I'm just trying to make a point that the numerator is the exponent, it's the power, and the denominator is your index for your root. Okay, so on number 2, a to the 1/5, it's the 5th root of a to the first power. So look at number 3. Number 3, a to the 4 over 9. So written in radical form, 9 is your index of your root. The 4 in the numerator is the power. Okay, so let's look at the next part. Change each of the following into rational form. So on number 5, they're giving us a radical, and we want to write it as a rational exponent. So the power for the y right now inside the radical is the first power. It's not written there, so it's understood to be the first power. So to write that in rational form, I'm going to have y to the 1/3 exponent. And I don't write a root for that anymore because the rational exponent takes care of the root. So on number 6, that's the 8th root of c, and c is to the first power again because there's not anything written there, so it's understood to be 1. So as a rational exponent, it would be c to the 1/8. Okay, so let's look at number 8. On number 8, you have radical w to the 3rd power. Okay, but there's no index. There's not a number written that tells you what the root is. So since there's nothing written there, it's understood to be a square root. So you could put a 2 there if you wanted to show that it's a square root. Not necessary, but you could do that. So writing this as a rational exponent would be w to the 3/2. So your power is in the numerator, the root, the index is in the denominator. Okay, so if you're having any trouble with that, make sure and put a question mark or, write down your questions so we can go over it tomorrow in class. All right, so number 9, we're going to evaluate. So that means I want to simplify it so that I don't have any more negative exponents. I have no fractional exponent in the denominator if I have the number as a fraction, which this one is going to be because I have that negative 1/4. I don't have a complex fraction, so I don't have a fraction and a fraction, and the index is the smallest number possible. The first thing you want to do with these type of problems when you want to simplify or to reduce the expression is look at your base first. In this case, the base is 16. 16 is a composite number. It has more factors than just one in itself. So what I want to do is I want to rewrite 16 as a base to a power. I want to find the prime factors and write it as a base to a power. So if I do a factor tree, 16 is 8 times 2. So I have 4 times 2, and I'm going to bring down my prime number so I have everything on the bottom. So what I wind up with is 2 times 2 times 2 times 2. So written as a prime number raised to a power, that is 2 to the 4th power. 16 is 2 to the 4th power. So all I did was rewrite that 16 as a prime number raised to a power. So I'm going to take that 16, put parentheses around it, and write the negative 1/4 outside the parentheses. Okay, so these rational exponents, all of the properties of regular exponents apply, all the properties of fractions apply. Okay, so what I'm going to do now is I'm going to simplify this power to a power. When you have a power being raised to a power, you multiply them together. So this is actually going to work out to be 2 to the negative 4/4. And the fraction 4/4 simplifies to 1. So this is 2 to the negative 1 power. And now I'm going to deal with that negative exponent. Since the 2 has a negative exponent, that means I want to rewrite this. See, it's over 1 right now. It's a whole number. So the negative exponent is telling me to move the 2 to the other side of the fraction bar. And after you move it to the other side of the fraction bar, the exponent becomes positive. So your answer is going to be 1/2. And no, you don't have to have this exponent. I'm just making a point with it being there. So that's your answer, 1/2. Okay, let's look at number 10. We're going to work a few more of these, and then we're going to take a break, and we'll come back and work some of the examples at the bottom. So on number 10, we have 243 to the 3/5 power. And I'm going to find my prime factors for 243, so I can rewrite that number as a base to a power. So 243 is divisible by 3, and that goes 81 times. 81 is 9 times 9. So I can see my prime factors are going to be 3 times 3 times 3 times 3 times 3. So I have 5 factors of 3. So I could write the 243 as 3 to the 5th power. Then I'm going to put my 3/5 exponent outside the parentheses. Okay, once I have the composite number written as a prime number raised to a power, now I can simplify the exponents. When you have a power raised to a power, you multiply them together. So that's going to be 3 to the 15/5 rational exponent. And that's going to simplify. 15 divided by 5 is 3. So you're going to have 3 to the 3rd power. And you do want to go ahead and multiply it out and get just a number with no exponent anymore, and that's going to be 27. So your final answer is 27. Okay, so if you're having any trouble or you have questions, make sure and write down your questions so we can go over this. Let's do one more and we'll take a break and come back and work some of the bottom problems. Let's look at number 11. Number 11 is 32 to the 2/5 power. Okay, so first thing I want to do is rewrite the composite number 32 as a prime number raised to a power. So I'm going to break it down using a factor tree. 32 is 8 times 4. 8 is 4 times 2. 4 is 2 times 2. So I'm going to have 2 times 2 times 2 times 2 times 2 as my prime factors. So I can write that as 2 to the 5th power. And write my rational exponent outside the parentheses. Multiply my exponents together. Have a power raised to a power, you multiply them together. So that's going to be 2 to the 10 over 5 power. The fraction 10 over 5 is going to simplify to 2. So that's 2 squared. And your final answer is going to be 4. Okay, so let's take a break. Come back and we're going to work some of those bottom examples.